And at Wix, once we were finished with the migration, we managed to drastically improve the development velocity for our developers. And for instance, you can see here that one of our larger repositories that has hundreds upon hundreds of Maven modules, on average, if you want to build the entire repo with Maven and run all of the tests, no matter what you change in your code, if you want to run everything, then it takes about 45 minutes. Now, with Bazel, once we did the transition, on average, depends on the size of your change of the code, usually takes less than a minute to run all of the compilation and all the tests. So that's a great win for Wix. And a few words for Wix Backend. We have roughly 250 developers, more than 750 microservices, over 10 million lines of code, mostly in Scala, but there is also Java, of course, and Node.js. And we have thousands upon thousands of builds every single day, and continuous integration, and you can also easily reach production. Yeah, so we migrated from Maven, and we ran it. Our CI server was TeamCity, and we really had quite difficult times, especially when any infrastructure code changed. So we have a lot of microservices, a lot of code that depends on the same infrastructure. So any small change there meant that the queue in TeamCity really exploded to thousands of modules that need to be built, and it took hours sometimes to get depleted. So our developers were very, very happy that once we did the transition to Bazel and switched from TeamCity to Google Cloud, usually for all of the repositories that get triggered, the build is only a few minutes, no matter what the change was, even if it was something extremely infrastructure in the root of the code. Okay, so now that you see how Wix enjoyed working with Bazel, I will quickly describe the key features that make Bazel fast, correct, and scalable, and also what works a bit, still has some room for improvement. And of course, how we migrated Wix to Bazel and what you will need to do to get a successful migration. So the one important thing to know about Bazel is that you control the level of granularity of your build. So unlike traditional build tools like Maven or Gradle, where you have the modules or projects and you have the structure that implicitly implies what are the build targets, with Bazel, you have the control here. So you may choose to build one single source file, like a.java here. You can also choose to have the package level granularity, and then each package will be built separately. Or you can have a set of packages like the normal structure of a Maven module. Now, these basic build units are called targets, and a target is an instance of a rule. So what is a rule, you may ask? A rule is basically a function that gets a set of inputs and provides a set of outputs, usually files, and there are many different kinds of rules. So basically, with Bazel, it's a generic build tool. You have your targets and dependency graph, and they can be of any type that adheres to something that has an input and provides an output file. So we have a Java library that will output jars, or C++ binary that will output the correct binary according to platform. Or we have Python tests that we want to run, or shell scripts that need to get executed, and many, many more different kinds of rules. It's a rich ecosystem supported by a big open source community. And Wix as well has contributed some rules that it found lacking for its needs. So it's a very rich environment of plugins or rules for Bazel. Now here you can see an example for Java. So we have an a.java source file that we want to build, and we have a target called A, but it also depends on target C, which in turn has this c.java source file. And basically this Java library rule and the target will create from these dependencies a.jar, very simple. And the way you execute it is you run Bazel build :a if you're in the relative directory where this package is located. So that's quite simple. And let's talk more about what are these rules. So you can have source files and dependencies on other targets as inputs, like I showed you in the example. And also, you can have other kinds of inputs. For instance, the Java compiler options are also considered part of the input for the rule, or which JDK version you are using. It's also a very important part of the input. And why is that? Because Bazel is very explicit and deterministic in its approach. It will execute all these rule's actions in a sandbox environment, meaning that if, for instance, you have some implicit dependency on some file in your code and you didn't declare it in your build configuration, there's a good chance your build will fail because Bazel will not allow access to this implicit dependency. You really have to explicitly define all of the dependencies. And also, if you run on a different platform or anything that is a little bit different, that means that you'll have a different cache hit, a different cache key. So this strong property with the sandboxing and hermeticity really gives us deterministic builds. So no matter how many times you're going to run this at the actions for this rule, you will always get the same result. And that's a very powerful key feature. Okay, so I mentioned that you have flexibility in the amount of targets that you can define. And usually that means you have many, many small targets with Bazel, usually much smaller than the way you'll be with Maven or Gradle. And that gives you quite a good leverage. It means that any change to any of these targets will not have a big impact. You know, it's a very small time to run a small target to compile or test. And also the dependencies, will also be limited in scope because it's a smaller part of the dependency tree. So as long as you have quite a good independence between these targets, you can achieve a much higher degree of parallelism than with Maven and Gradle. So here you can see that not only you get stuff running in parallel, you also have compilation and tests running at the same time. So the blue targets have already finished their compilation, so they're running tests, and their dependents are starting to run compilation at the same time. And you're only constrained here by the local amount of CPU cores you have for the level of parallelism. And of course, once you run all of these actions because of deterministic properties, you can put them in the cache, and Bazel will later analyze it for subsequent runs and know, hey, the set of inputs is exactly the same as before, so I know the set of outputs is exactly the same. I don't need to rerun this. And also tests, if the test code hasn't changed, I don't need to run these tests. So sometimes integration tests can take several minutes or even more to run, and Bazel will just understand that there's no need to rerun them. And furthermore, you can get out of the limits of your local machine or your CI server machine and utilize a worker farm in the cloud. So you just send each build or test action separately to a remote worker and just run everything in parallel. So you have the same sandboxing principle because it's a very limited Docker container that runs them. And we use at Wix Google Cloud Platform, and we actually use hundreds upon hundreds of workers at the same time, so it's crazy level of parallelism. There are also open source solutions with the same remote execution protocol that you can use to set up these workers. And of course, once these workers finish, they populate the remote cache. So CI server can reutilize this cache for the next runs. And you can also utilize that remote cache locally. But there is a constraint there. I will mention it later in this talk. Now you can also decide, well, there's some trade-off here, right? Because I'm in my local machine and I'm running these actions remotely, so there's network latency, right? So there is a new experimental feature with Bazel. It's called dynamic execution, where you run both locally and remotely the action, and the slowest action will stop executing the moment the faster one finishes. So you have the best of both worlds, both local and remote, and that's a very cool feature to have to harness the power of both platforms. Okay, so these were a few of the cool basic features that Bazel has, and I really think Bazel is worth the effort. So I talked about if you run this Wix repository with Maven, and you usually want to clean so you know nothing is messed up, then it takes 45 minutes. Now, if you take the same repo and build it with Bazel locally, but without using any cache, you have a clean build, it drops down to 20 minutes because of the higher degree of parallelism I mentioned. And if you take the same build and run it on the worker farm, but again, without using any cache cleanly, it already drops down to 8.5 minutes because of the even higher degree of parallelism there, but you still have a lot of dependencies in the graph that can run in the same time. So you are constrained by that. And of course, when Bazel analyzes the cache on the next run, it will see that it doesn't really have anything to execute if nothing has changed, and it only takes a small number of seconds to realize that, and the build will finish. Now, I don't think that Bazel is worth it in all cases. So for instance, if you're a small startup and you have a small code base and you just want the tools that you're using to just work out of the box, no hassle, then Bazel is probably not the right tool for you at this moment because there is a steeper learning curve. And your code needs to adhere to the sandboxing principle, both for file system and network. So you need to make sure that you don't have files that you just write to somewhere in your file system. So there's a bit more hassle when you write code, but you do get the benefits. So I wouldn't recommend it for a small code base. Now, once your code becomes larger, you have many more interdependencies. It gets more complex. You have more testing. You want quality. You have integration testing. Then maybe it's time to consider Bazel, because what I think you want to avoid is to compromise between quality and performance. You want both to have your builds fast, get to production fast, but you don't want to say, you know what? These integration tests don't really matter that much. I'll just run them each night, and I'm sure it'll be okay. We can find out if there is an issue in the morning. So no. Why should you compromise? Just decide that you want to have both, basically. And of course, if you have a very large code base, millions upon millions of lines of code, I would highly recommend switching to Bazel because the overhead and the learning curve are just worth it because you get great performance and great correctness and accuracy as well. So you can rely on it. Okay, so this was a few minutes talk about what Bazel is, what the cool features are. But now let's get into the nitty-gritty of migrating. So maybe I piqued your interest in migration to Bazel. So these are the 5 key things that you need to think about when you consider migrating. The first one is to choose the granularity for the migration. So you can either keep the Maven Gradle granularity, or you can have the package granularity, which is finer grained. Now, what about the performance gain? So keeping the Maven granularity means you'll have more coarse grain targets, so you have less optimal performance than the smaller grain package granularity, because any small change you do will need to rerun the entire module worth of configuration. And what about the ease of migration? So if you keep the Maven Gradle granularity, that's pretty straightforward. You just need to encode the same dependencies that you get in your POM files or your Gradle files. Just transfer them to the Bazel syntax, so that's pretty straightforward. But if you choose the package granularity, that means you need a more sophisticated tool that will analyze which source files depend on other source files and get the correct package level dependencies. So at Wix, we created this tool that does the automatic analysis and migration for you. And I'm happy to announce today that we have our first official release of Exodus. That's the name of the tool. And you can download the release from this link and try it out. And now I'll show you a quick demo of how to do the migration automatically with Exodus. So here there's, I hope, can you see the font? I hope so. So here we have a simple Java repository that is open source, of course. And it's Java design patterns, and you have like abstract factory and stuff like that. I narrowed down the modules for simplicity's sake. And there's stuff like factories here, simple Java code. So the first thing you want to do is to run the Maven install command. And the reason that you need to run this command is because for these, once you do that, well, the first thing you need to do before you run this command is to set up the Scala Maven plugin and set it up for recompilation mode incremental. In this case, it will use the Zinc incremental compiler that has as its output some analysis file that are very cool that you can actually get for each source file what are its dependencies here. So that's what Exodus needs in order to actually do the package graphs, package dependencies, package level dependencies, sorry, and manage to do the migration correctly. Okay, so Maven is finished. So now we can run Exodus. So you just give it as the parameters the name of the repository and just the GitHub repository. So that's quite simple, and it's finished. So now we can see that it has created all of the needed configuration for Bazel. So this is the workspace file, and it defines all of the external third-party or second-party dependencies that you need for your repository. You can also see all the build configurations that are for specific packages. So we have a Java library for the abstract factory production code package, and we have the Java JUnit 5 test target for the test code package inside this module of abstract factory. And something else that's quite interesting is, I'll show you here, that, like I said, this tool tries to figure out the package level dependencies. Now, sometimes there are cyclic dependencies between these packages, right? Because package A depends on package B, but package B also has code that depends on package A. So this is exactly the situation that happened in the iterator module, that these packages, BST list and the root package, have cyclic dependency between them. And Bazel does not allow for that. So what Exodus did, it created an aggregate target out of these 3 packages in order to avoid the cycle and get a successful build. And you can see that the test of the iterator and the BST package, each one has a separate target for the test, but they all depend on the production code aggregate target. And also you have here all the third-party dependencies that you need in order to, of course, have a successful build, like the JUnit platform and Jupyter for JUnit 5, etc. So now let's see that the Bazel build has actually worked. So let's run Bazel test / /.. That means run all of the targets that you find in the repository, first build them, and then, of course, if you can in parallel, run the tests. Oh, of course, I forgot to first clean all the Maven outputs in order not to confuse Bazel. Okay, so now you can see that Bazel is starting to run, and it uses all of the available cores if it can. And it's building and testing. Now it switched over to testing, and it's finished. So imagine a bigger code base. You can see that it utilizes all of the 8 cores, so it has a quite good performance. And the last thing I want to show in the demo, if we just change some tests. So let's choose some tests here and just fail it. So I'll get a failure in the assertion. So all I have to do now is rerun the entire repo. I don't need to think about it. And you can see that Bazel understood that all of the other tests and compilation, everything is already cached. So it just needed to rerun the fail test. And it actually indeed failed. And if, of course, I bring it back to being correct and run the same command again, then again, it only saw that it needs to rerun that test, and it passes. So there you go. That's Exodus and a quick demo of Bazel. Okay. So the second thing you need to decide about is the amount of source control repositories. So Bazel is optimized for one big monorepo. Maybe you've heard that term before, monorepo. And that's how Google work. They have all of their code in one big repo. Now, for Wix, we used to have hundreds of repositories, close to 1,000 repositories for Wix Backend. And we knew that that would be problematic for Bazel. So we decided to do a consolidation and move to one repository per domain. I'll explain a bit later what were our considerations here. So if you have more than one repository of source code that you want to run, so Bazel will need to depend on the source code of another repository. So you just define this in the workspace file, have a Git repository from somewhere else, and what you can follow master, branch, or specify a specific commit. And it will be like you have one virtual monorepo with all of your source code together. So what are the different challenges here? So we want to trigger the build once some code has changed. But we have, so with one monorepo, it's trivial. You just build the entire repo like I showed you with that command. Now, if you have many repositories, you probably need to start managing what you want to trigger, because there's a big chance that some repositories don't depend on many others. So do you trigger everything? Probably not. You probably, well, In the naive case, you will, and you have false triggering of builds that is just redundant, or you'll need to manage it, which is quite cumbersome, and what code depends on which other code. It's quite tricky. Now, if you only have a few repositories, then that means there'll be possibly quite greater cohesion and interdependencies between them. So you probably have less false triggering. Now, what about managing this list of Git repositories that I showed you? Well, if you have many repositories, that means that people just spring out new repo whenever they want, and that means that you'll need to have some mechanism to discover that and incorporate it into some server that will give you all the repositories and the updated ones. So you'll need to manage it dynamically. But if you only have a few repositories, you can have just a static list, and once in a blue moon, you just add a new repository when your company decides to work in a new domain. Now, why do we even bother with all of this work on a virtual monorepository with several repos? That's because Git and GitHub do not currently support the scale that Wix code has. So more than 10 million lines of code, a lot of code, and we just, when we did the POC, we saw that git pull, git push, and clone will just be too much. So we decided to do this consolidation, and it works pretty well, but we really do want to move over to a monorepo when we can. We'll have all the source code, one place, easy to search, easy to add a dependency. And Microsoft has a very interesting project that has a virtual file system for Git. It has it for Windows. It's working on a Mac version, and hopefully it will be robust and stable enough for us to move to one monorepo. We hope to do that soon. Yeah, so that's what we chose to do. The thing you need to decide is which CI server to run Bazel on and which remote execution solution you're going to use. So the two basic options here, you can go open source route, or you can go with Google Cloud. But of course, you can choose any CI server you have, but it's just a matter of preference. So with Bazel, like I showed you, you just build the entire repo. And that means that you need some UI that will help you figure out what happened to specific targets, specific set of targets. And currently, unfortunately, there's no open source views for that. There's no Jenkins plugin or something like that. You can see here that Google has a solution for that. You can see all the successful targets in the view, and you can see all of the failed targets, and you can filter according to some area in the repository that you're interested in. And hopefully, they will just release this as a separate product. But I'm not sure that's the current situation. Now, what about a dashboard? A good dashboard that you can see everything that's going on about your builds happening in your repository and history, etc. So Jenkins, for instance, with open source has a very good dashboard capability. Currently, the Google solution lacks in this area. You have one view where you'll have all the information for all your repositories, and you can filter. You can say, I want to look at one specific repository and one branch, but it's quite cumbersome. I do know that Google are working on having specific Bazel dashboards, so they'll announce that in the future. Okay, what about remote build execution? So there are open source solutions for that, several of them, and companies are using them, among them Uber, I know, but you still have the need to set it up yourself and to manage it, and so that's not for everyone. Now, Google has the remote build execution solution, and it's currently in alpha, but we at Wix are using it, and actually we're very satisfied with it. It's very stable, very powerful, and we're really pleased with it. You can also split up cheaper actions and more costly actions to cheaper and more costly machines. So you can get a little bit less bill in your bills for the Google Cloud Platform. Okay, the fourth thing you need to think about is your local dev experience. All of us are probably developers, and we sit in our stations and develop on our favorite IDE, and we want to have a good experience. So how's the experience like with Bazel? So Bazel is really optimized for working on Linux. That's how Google work. They have their remote machines for each developer that runs Bazel on them. Now, you can utilize the remote cache for your Macs, even though that you haven't the one that populated it, but it will need to be a separate one from your CI server, the standard CI server that probably runs on Linux, usually. So that can be an added cost, unfortunately. Now, the compilation time is really good both for Linux and Mac, especially if you use a separate cache for Mac. But parallel testing does not work well on Macs. So Mac has a good sandboxing solution for file system, but it's not working well for networks. Sorry. So you'll get possible port collisions if you run in sandbox. That means on Macs you need to disable the sandboxing property of Bazel, and you need to run integration tests sequentially. Now, our developers at Wix solved this issue by just finishing writing the code, running unit tests, and then just pushing the change to a branch and letting the CI server run these tests and get a very fast feedback. So it's not optimal, but that's what we do at the moment. Now, Intellij Support you have it for both Linux and Mac. And actually, I would say it's between green and yellow at the moment, especially the official one from Google. We at Wix are working very hard to have a seamless experience with Intellij, that you just write your source code, add your imports, and get all of the dependencies that need to be added for the build configurations behind the scenes and without you needing to keep up the maintenance. Because we went down to package level, that means many more dependencies, many more build configurations. And hopefully, we'll open source these tools soon so that everyone can enjoy them. Now, we did want to somehow resolve the Mac issues for Bazel. And what we try to do is just get a Linux container running on our Macs. So we did manage to get the same cache of the CI server to work on our Macs using this Docker solution. And also parallel tests were running seamlessly without any collision, any issues because of the networking sandbox in Linux inside the Docker. But the compilation time and IntelliJ, IntelliSense suffered when we did the solution because of file syncing. So IntelliJ, for example, needs to have the files that Bazel outputs in order to understand what's going on. No matter which file syncing protocol we tried the native Docker sync, we tried NFS, Samba, or rsync. No matter what we tried, it was always either unstable and unreliable sync, or it was reliable in the case of rsync, but it was very, very slow. So it wasn't useful. So we needed to drop this Docker solution. I do know that there are companies working in Bazel that do run Bazel in the cloud, but usually they won't get the good IDE integration. They work maybe with some editor, and they won't get the IDE. So if you like working in command line and just sending Bazel to remote workers, that may be good for you. I really hope there's promising work in the VS Code area that we'll be able to switch to having VS Code running against a remote server, that they have this feature, We just need Bazel to implement the build server protocol that works with VS Code and can work with other IDEs as well, and then enjoy both good VS Code integration and the fast running of Bazel on Linux. But of course, some people will still want their IntelliJ that they know and love. Okay, the last and final thing that you need to think about is third-party version resolution. Now, Bazel is optimized to have one version for each of the third parties in your repository. So we saw the workspace file where you define all the third-party dependencies. So you just have usually one definition. And that's unlike Maven, that you can define for any specific module, what is the specific version that you want. So you can have multiple versions per repo in Bazel, but it will be unnatural. For instance, when you migrate, you want to have the dependencies that came from Maven, also the transitive dependencies, in your Bazel repository, because with Bazel you need to define everything explicitly. I've already mentioned that to get the sandboxing and deterministic builds, everything is defined explicitly. So you need to have a resolution tool that understands the Maven dependencies and writes down all of the graph. And these tools already they expect that you have one version in your repository. And if you do want to have multiple versions, you'll need to set it up like maybe in the name of the target you had underscore version. So it's not natural in the Bazel configuration. And also it's fragile. You sometimes maybe get to a situation where your target will depend on two different versions at the same time, and only one of them will get to the class path, and you can have undeterministic behavior. So that's bad. So at Wix, we decided to go with one version per repository. Furthermore, we tried to have all of our repositories have the same version, because we believe it makes our code better. We keep upgrading the version, so everyone is at the highest version at the same time. That means bug fixes, that means security issue fixes, maybe performance fixes for our libraries, and just keeping up. And it makes our code just better, and you don't incur technical debt. So yes, whenever we upgrade a version, that means that developers will need to fix their code if there is an API breaking change. But we believe it's for the best. Yeah, so that's what we chose. Okay, so this was a rundown of 5 things that you need to think about. So you see, there's quite a lot of things to do when you want to migrate to Bazel in order to get all the benefits. So what my promise here is that Bazel is worth it. You get faster, reliable builds, and the ecosystem is becoming better. So we have now the automatic migration tool from Wix, and we have the developer tools for IntelliJ, for instance, that we're working on in Wix, and we really hope to open source that soon and get everyone to enjoy it. And like I said, the migration is becoming easier. So if you're interested and want to know more about the migration stories, you can see my migration story with 5-part series on my blog, or you can follow Redfin's story, and Salesforce has a video on how they managed to do the migration. Yeah, that's it. Thank you very much. So does anyone have any questions?
Yeah, let's begin the questions part, and I'm going to handle the microphone. So if you have a question, raise your hand, I'll bring it to you. You can answer the question. When the speaker answers the question, you hand it back to me, and I will find the next person asking.
Hello.
Hi.
You mentioned the cache tests, so when some modules are changed and others aren't, the unchanged modules don't get tested. But is there a case where certain dependencies that do get changed alter the results of those tests? Is that something that you have considered, and does that ever come into play?
So you mean like runtime dependency or something like that?
Yes, yes.
So you have to explicitly declare both compile time dependencies and runtime dependencies. So if, like you said, some third party or something like that has changed, that means that the hash will change for the test configuration. That means the test will get rerun. So as long as you explicitly define everything, you'll get correct and fast results.